All right, let's look at linear approximation. All right, sometimes the original function is so complicated, it's very difficult to find the value. So if you can find its tangent line and use the tangent line to approximate the value of the function. So we're going to try to get the ballpark value. All right, so this is here's how it goes. All right, so let's say you have original function f of x, so this is the purple curve, right? And then let's say you want to find the function value f of x. Maybe I can use a different variable, but f of x. So you can see that the f of x is, the value is right here. It shows up f of x right up here, right? But instead of using the complicated original function, we're going to try to find the tangent line to some point A fairly close to x, right? Then use this tangent line, which is going to be a linear function, obviously, and use that to approximate the value of f of x. So this tangent line function, we're going to call it the linearization, so we're going to call it L, all right? Then the corresponding value at x is L of x, right? So if, A and x are fairly close to each other, then we can see that the function value f of x and linear approximation or linearization are going to be very similar. Only difference is that this little gap right there. All right, so this is the idea. All right, and we can easily come up with the linearization L of x. Simply, this is just a tangent line equation. I remember that the tangent line can be found y minus f of a equals f prime of a, which is the slope, and times quantity x minus a. So all we have to do is add f of a to both sides so that we isolate y. So we have y equals, right, f of a. So I'm going to just move f of a over to the other side. Then you have exactly the same thing. So you have f prime of a times quantity x minus a, right? And we're going to call that a function. So I'm going to call it L of x, right? So this is the linearization of function f at x equals a, right? But that's a fancy word for tangent line equation at a. All right. So how do we use this? All right. So here's the following example. All right. Let's use linearization to approximate square root of 25.1. All right, so I'm going to use the function since it's a square root, so I'm going to use square root of x as the function, right, to work with. All right, and another thing is I want something close to square root of 25.1. So I'm going to use, let's see, I'm going to use a to be 25, right? So I'm going to take a to be 25, which is fairly close, right? All right, so let's find the linearization. All right, so we need to find f of a. So let's find that. So let's see, f of a. In this case, a is 25. So this is f is square root of 25. All right, so that's going to be 5. All right, we found that. All right, and we need the derivative, so I'm going to go ahead and take the derivative. So f prime of x is going to be, all right, so this is a 1/2 power, so put 1/2 in front, x and subtract 1 from 1/2, negative 1/2. So this is 1 over 2 times a negative power, so x is on the bottom, and the 1/2 power is square root. So we have that. All right, so what would be f prime of a? So f prime of 25 is equal to, let's see, 1 over 2 times square root of 25. And that's going to be 5 times 2, so 1 over 10. Or 0.1, either way. All right, we have that. So the linearization is going to be L of X. We just plug in those numbers. So f of a, so f of 25 is 5, and plus. F prime of a is 1 over 10, x minus 25. All right, so this is a linearization. All right, so what we are trying to find is this, right? So actual value we're looking for is f of 25.1, right? Which is square root of 25.1, right? But what we want to do is we want to approximate that value using that linearization. So this is not the same, but it's going to be similar to linearization L of 25.1. That makes sense? All right, so once you've done that, the computation is fairly easy. Actually, we can probably do it by hand, right? So this is going to be equal to, right, 5 plus 1 over 10, and then x is 25.1 and minus 25. So you can see that this is going to be, let's see, 25.1 minus 25 is 0.1. Divided by 10 is 0.01. So it's going to be 5.01. Alright, so this is the approximation, linear approximation of the value of square root of 25.1. Alright, is this approximation reasonable? Alright, let's try to check. Just put it in the GeoGebra. Alright, so let's see. I'm going to make this a little bit smaller here. Alright, so we want to find the value of square root of 25.1 and hit enter. Right? So actually I want to see a little bit more precision here. Alright. So square root of 25.1 came out to be 5.00999, and our approximation is 5.01. You can see that this is pretty darn close to the actual value. This is not quite actual. It kind of keeps on going, but you can see that our approximation is very close to the actual value. All right. So that is called the linear approximation, just using the tangent line to approximate the value of the original function. All right, that's it. I hope that this was clear.